Hello everybody, this is Mrs. Snook with section 4.4, and what we're going to do today is evaluate trigonometric functions of any angle. We're going to find reference angles, and we're going to evaluate the trig functions of real numbers. So let's go ahead and get started. So we're going to use the point -3, 4, and that's going to be the terminal side of angle theta. Let's go ahead and draw this onto our graph. I'm going to put in an xy axis. Here's x. Sorry, that's y. Here's x. This is x, this is y, and my point -3, 4 is going to be right here. 1, 2, 3, 1, 2, 3, 4. There's my point. So here's my angle. Initial side is on the x-axis. Terminal side is going to go through that point. So right here is angle theta. Now we are asked to find the sine, the cosine, and the tangent. So think back to your right triangle trig. Right here and here we have a right triangle. This length here is -3 because my point is at -3, 4. This length here is +4, and we're going to call the length of the hypotenuse r. And when you're in the coordinate plane, you need to know all three sides, all three lengths. So I have a right angle right here, so I can use Pythagorean's theorem to get r. So r squared is going to be x squared plus y squared. That's Pythagorean's theorem. Just plug in what you know. So r squared is going to equal -3 squared plus 4 squared. So r squared equals 25, which means r equals 5. All right, so now we have everything we need to know to do the sine, the cosine, and the tangent. In the coordinate plane, sine of theta is going to be y over r. So we're going to do 4 over 5. That's the sine of theta. Cosine of theta is x over r. So that's going to be -3 over 5. And tangent theta is y over x, which is going to be 4 over -3. And you can just rewrite that as -4 over 3. And if you're wondering where are these coming from, go back to your right triangle trig. From here, y is opposite, 3 is adjacent, and your r is your hypotenuse. So just remember that. So sine of theta is opposite over hypotenuse, in this case y over r. Cosine's adjacent over hypotenuse, so x over r. Tangent is opposite over adjacent, or y over x. Next up, we're going to evaluate a trig function. We are given that sine of theta is -2 over 3, and tangent of theta has to be positive. And we're asked to find the cosine and the cotangent. First thing we need to figure out is which quadrant is this in. Now remember, sine of theta is y over r. This is negative, so our y is going to be negative. That means we're in either quadrant 3 or quadrant 4. We know that tangent is positive. Tangent is y over x. The only way I can get this to be positive, since y is already negative, is x has to be negative as well. So that narrows it down to quadrant 3. And if you look right here, you have the negative cosine because x is negative, which then results in a positive tangent. So quadrant 3 is our answer. That's where we're going to find our answer, I should say. And so now we're going to use what we know about cosine and cotangent. Well, first of all, I have y is 2 and r is 3. And my cosine of theta is going to be x over r. I don't have x, but I do have y and r. So r squared equals x squared plus y squared. R is 3, so 3 squared. X squared, that's what I'm looking for. And y squared is negative 2 squared. So I get 9 equals x squared plus 4. That tells me my x squared equals 5. So then x is going to be the square root of 5. That looks like a 6. We'll make this a 5. And rule of thumb, when you put in the square root, you take both positive and negative. So I had to write square root in there, so I'm taking both positive and negative. But I know I need to be in quadrant 3, so therefore I want the negative value. So my x is going to be negative root 5, because that gives me quadrant 3. So I've got x. That means I can get my cosine. So my cosine of theta is going to be negative root 5 over r, and r is 3. I get negative root 5 over 3. There's my cosine. Tangent, I know, is y over x. So my tangent of theta is negative 2 over negative root 5. Sorry, we didn't want tangent, we want a cotangent. Let's back up. Cotangent, that's the tangent flipped over. So instead of y over x, I'm going to do x over y. X is negative root 5, and y is negative 2. My negatives cancel, so then my cotangent of theta is root 5 over 2. All right. Next up, we're going to do the quadrant angles. So I'm going to draw a picture of my angles. Here's my x-axis, and here's my y-axis. First one is 0. So that means the angle's right there on the x-axis. Sorry, I wrote my coordinates backwards, 1, 0. And that one's 0. Pi over 2 is going to be up here. That's going to be on the x-axis. That point is 0, 1. Pi is going to be negative 1, 0. And 3 pi over 2 is 0, negative 1. And let's go ahead and label this. So this is 0, pi over 2, pi, and 3 pi over 2. Now keep in mind that our sine is going to be y over r, and cosine is x over r. So what's r? Well, check it out. For each one of these, I made r just 1 unit. Okay, so for all of these, r equals 1. All right, so let's go ahead and get the sine and cosine of our functions. I'm going to make a table. So sine of theta, cosine of theta, and here's our theta. We've got 0, pi over 2, pi, and 3 pi over 2. All right, so sine of theta is 0 over 1 equals 0. Cosine of theta, that's going to be your x, 1 over 1. Okay, pi over 2, sine of theta is going to be 1 over 1. That equals 1. Cosine of theta, 0 over 1 equals 0. Okay. Pi sine of theta 0 over 1 equals 0. Cosine of theta negative 1 over 1 equals negative 1. Last one is 3 pi over 2. Sine is going to be negative 1 over 1, so that equals negative 1. And cosine is going to be 0 over 1, so that equals 0. Now we've got all of our functions. All right, the next idea is to find the reference angle. And we're going to use the reference angles to evaluate trig functions if they don't appear on our unit circle. That can be helpful there. So let's do some examples of that. First thing I'm going to do is I'm going to draw in the coordinate plane. Here's x, here's y. And then let's draw in our first angle, so 300 degrees. Initial side is always going to be on the x-axis. This is 90 degrees, 180, 270. This is 0 and 360. So 300 degrees, that's going to be round about there somewhere. So 300 degrees. Now your reference angle is the shortest distance to the x-axis. So that's going to be this one right here. And we use the notation theta prime for reference angle. And then over here, going this way, that's theta. So I'm trying to find theta prime. Shortest distance to the x-axis is what I'm looking for. And my answer has to be a positive number. So I'm going to find this distance right in there. And I know this is 360 and that's 300. So I'm just going to do 360 minus 300. So theta prime is going to equal 60 degrees. Okay. Next one, we have theta is 2.3. So I'm going to erase this. And this time 2.3, we're not given any units. We're not told that that's degrees or radians, so therefore assume radians. So now if I'm going to label, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. I'm at 2.3 radians. Pi is approximately 3.1. Pi over 2 is approximately 1.57. So 2.3 is going to be somewhere in here. So right here is theta. That means theta prime is right here, shortest distance to the x-axis. And then to find theta prime, I'm going to do 3.1 minus 2.3. And I get 0.8. Okay. Last one is a negative 135 degrees. So let's reset our frame. Negative 135 degrees. Well, I don't have a negative. I'm going to find myself a coterminal angle. And I do that in degrees by adding 360. So 360 is 225 degrees. So that means that my angle is over here somewhere. And this is 225 degrees. So then my reference angle, shortest distance to the x-axis, so that means this one is theta prime. And all the way around, that's theta. I'm going to put theta over here. And the reason for that is that we started off with a negative angle. All right, so there's our reference angle. We've got it marked. I just need to find the difference between 225 and 180. So 225 minus 180. Remember, my answer needs to be positive. That's why I put 225 first. Is 45 degrees. So there's our theta prime, 45 degrees. Okay. So now we're going to start putting these things together. We're going to evaluate the trig function at these specific locations. And instead of going to our unit circle, we're going to use this table that has common trig functions. This is in your book on page 287. And you do need to memorize this. No, I'm sorry, I don't like memorizing, but we have to memorize it. So for the first one, cosine of 4 pi over 3, here's how we're going to do this. First thing we need to do is find the quadrant. The second thing we need to do is find the reference angle. And then the third thing we're going to do is we're going to go to the chart to get the value that we're looking for. The first one is 4 pi over 3. So I'm going to draw myself a picture. So 0, pi over 2, pi, 3 pi over 2. 4 pi over 3 is round about here. There's our initial. So right in here is our reference angle. So what I'm going to do to get that reference angle, I'm going to do 4 pi over 3 minus pi. So I'm going to do 4 pi over 3 minus pi. That gives me pi over 3. So I know that I want cosine of pi over 3, which right here is 1/2. And I also know that I am in quadrant 3. That means my x has to be negative. So my cosine value has to be negative. So instead of 1/2, I'm going to take negative 1/2. That's where the quadrant comes into play. All right. Next up is tangent of a negative 210 degrees. Now, another thing you can do when using negative angles, I didn't show you this before, but I'm going to show you another option. And that is we can count backwards around our circle. So instead of 0 degrees, and instead of going up here to 90, I'm going to come down here and say that's minus 90, minus 180, minus 270. It's a little bit easier to do it that way sometimes. So that means that negative 210, that has to be between negative 180 and negative 270. So right here is theta. And then my reference angle, shortest distance to the x-axis, is that way. So my reference angle is right in there. And to find that value, I'm going to say negative 180 minus a negative 210. And when I do that, I get 30 degrees. So my reference angle is 30. I want the tangent. So tangent of 30 is root 3 over 3. I am in the second quadrant. That means my y is positive and my x is negative. So therefore my tangent should be negative. So I'm going to take a negative root 3 over 3. And that's the answer for that one. Okay, last one is cosecant of 11 pi over 4. I'm going to reset my grid. So therefore this is pi over 2, pi, 3 pi over 2. So let's figure out where 11 pi over 4 is. 11 pi over 4, that's just a little bit less than 12 pi over 4. So when I'm looking at this, I realize that I'm pretty close to 3 pi. So 0, 1 pi, 2 pi, 3 pi. That puts it over there. So here's my angle. Whoop. And it went right around there. So there's theta prime. Sorry, not prime, there's theta. Therefore, theta prime is right in here. This is pi and 3 pi. And this one is 11 pi over 4. So what I'm going to do is I'm going to do 3 pi minus 11 pi over 4. I'm going to write over here because I need space. So 3 pi minus 11 pi over 4. I need a common denominator, which is going to be 4. So I get a 12 pi over 4. And that's going to give me pi over 4. So I want the cosecant of pi over 4. Now I got to think, cosecant, that's 1 over sine. I don't see a cosecant on my table, but I do see sine. So sine of pi over 4 is root 2 over 2. I am in the second quadrant. Sine is positive there, so therefore cosecant will be positive. So I'm going to take that root 2 over 2, and I'm going to flip it over. I'm going to get 2 over root 2. Now we cannot have a square root in the denominator, so rationalize. And I get 2 root 2 over 2. Those 2's cancel. So my answer for this one is going to be square root of 2. Okay, last example. Theta is going to be an angle in quadrant 2 such that the sine of theta is 1/3. So here's quadrant 2. Here's theta. Here's our triangle that we're going to use. Okay. So this is 1, that is 3. And we're going to find cosine. What we're going to do is using trig identities. What that means is I'm going to go back to those identities that we did before the semester break, and I'm going to pull out the one that was this one. Sine squared of theta plus cosine squared of theta equals 1. And then all I got to do is plug in what I know and solve for what I'm looking for. So I have 1/3 squared plus cosine squared of theta equals 1. So I get 1/9 plus cosine squared theta equals 1. So now I need to subtract 1/9 from both sides. Cosine squared theta equals 8 over 9. I'm going to square root it. And remember, I can take both positive and negative because I'm writing in the square root myself. So I get cosine theta equals square root of 9 is 3, and I have a square root of 8. Since I wrote it in, I'm going to take both positive and negative, but I'm in quadrant 2, so I only want the negative. Now I'm going to simplify the square root. 8 is 4 times 2. 4 is a perfect square, so cosine of theta is going to be negative 2 root 2. For some reason, I cannot write cosine theta. Cosine theta equals negative 2 root 2 over 3. And that's it for today's video. Thank you for watching and have a great day.